Today we're going to start taking notes on work, and we're going to do a couple of definitions, learn a new formula. It's going to be the same type thing that we've been doing in previous units, where you got a nice little triangle and we place the different variables in there. So let's go ahead and get started. So for work is applying force to an object to move or change direction of that object. Applying force to an object to move or change the direction of that object. When we're talking about work in science, it is not the same thing as somebody going to a job necessarily. It's not, you could have a job that is moving a mouse around and clicking a keyboard, and that could be doing a massive amount of work, but that's not what we're talking about here. When we're talking about work in science, the way that we're doing it currently, or in this unit, that work is going to be something different. That work is a formula. It's based on a formula. And that formula, you can see it down there at the bottom of the triangle. That formula is work equals force times distance. And we'll talk about that in a second. But essentially what you have to do is there has to be a force on an object, and that object has to be moved a certain distance. And so if I push on a wall really, really hard, there is no work being done unless that wall moves. Now, if that wall moves, then there's work being done. But if that wall does not move, then there is no work being done. So let's get to force. We'll talk about that more in here in a second. A force is a push or a pull. A push or a pull, and we've talked about this already in a previous unit. A force is a push or a pull, and force is measured in newtons. Force is measured in newtons, and you'll see that capital N in different places. Some examples of work, not examples of force, but examples of work, is pulling a box, rolling a ball, or pushing a car 10 meters. And if you'll notice in all three of those, there's clarification that the object is moving. So I didn't say just pushing a car, because I could push on a car, and if the car does not move, zero work is being done. Mathematically, if there's zero distance moved, there is zero work being done. It doesn't matter how much energy I use. It doesn't matter how much time and force I put on it. If it moves 0 meters, it doesn't move at all, then there is zero work being done. So some non-examples would be pushing a wall, and I'm putting in parentheses, that doesn't move. Pushing a wall that doesn't move. And again, work equals zero if the object isn't moved. If the object does not move, it is zero. And here's another thing. We're not going to come across this a whole lot, but just to clarify, if I have a 5-gallon weight in my arms or in my hand, and it stays still, like I'm not lifting it up or anything, if I'm kind of hugging it and I walk with it, if I walk 1 mile, there is zero work being done, because that weight is not pushing on any force. I'm not fighting any force to make it move side by side. Now, if I were to lift that weight up, I would be fighting gravity. And so that would be work, because I'm making it move a distance, and there's a force being applied to that thing, and it's there's a force that's fighting back. But if there's not a force that's fighting back, then there is not any work being done. So the work equals zero if the object doesn't move, and there is no work being done if there isn't a force being fought against. And what I mean by that, if you pick up a baby and you walk a baby from one side of the room to the other, then there's no work being done, because that baby is not fighting against gravity. Now, if you pick up that baby and it fights against gravity, then yes. If I were to have the baby on a little scooter and I push it sideways, so that baby is now fighting friction on the ground, and it is there's force, and it is work. So I realize that's a little bit confusing, and again, you should not see anything like that most of the questions are going to be as long as as long as there's a force being applied and that object is moving, there's a distance that it covers, then it is considered work. So let's get to the formula. Work equals force times distance. I hope that when I just explained that I did not mix up force and distance when I was looking at the word force. But yeah, so work equals force times a distance.